Hello and welcome to our panel discussion, Geoengineering, Clutching at Straws or Part of a Climate Solution Strategy, presented by the Academy for Responsible Research, Teaching and Innovation, ARRTI, at Karlsruhe Institute for Technology, KIT. I am Katharina Linnepe, and well, in my role as a journalist and out of curiosity when it comes to highly topical questions in science, I'm very excited to moderate this panel. This panel will be streamed on YouTube, and you will have the chance to pose your questions and discuss with us. And for that, you can use the live chat on YouTube. You can ask your questions on Twitter. Please use the hashtag ARRTIGeo for that. Or you can write an email to artivent@gmail.com. And you can find all the info you need for that in the description to this live event on YouTube. We will gather your questions and bring them in during our discussion, which is supposed to be a controversial yet respectful discussion, and same goes for the questions we invite you to come up with. So what is so controversial about our guiding topic? Well, when we talk about controversies, it's all about pros and cons, and this also applies for geoengineering, which means technological interventions, large-scale technological interventions in, as we explain it in our announcement, geochemical and biogeochemical cycles of the Earth. One example would be solar radiation management, and we will hear more about this, and others, of course, and also current approaches later, more in detail. And this is where we can assume the pros and the, or at least one, answer to climate change and global warming. And the number of concepts and approaches, and also their benefits, is quite promising. However, the list of potential risks and doubts is not short either, and covers a range of concerns regarding effects on the ozone layer, flora and fauna, or risks of unethical misuse of the technology. There's a lot to talk about tonight, as you can see, and to find out if we are really clutching at straws or perhaps have a solid climate solution strategy, or even a mix of strategies at hand with geoengineering. And we have a lot of experts here tonight who can shed light on the matter. But first, we will throw light onto the institution responsible for the idea and organization of this panel discussion, ARRTI at KIT. So the name ARRTI means Academy for Responsible Research, Teaching and Innovation, which is, well, already quite revealing. Responsible gives us a hint to the framework of the Academy. ARRTI's mission is to foster more responsible research and innovation. It aims to embed a broad responsibility for the unintended side effects on one's actions already in teaching. And this mission defines ARRTI's stakeholders as well, who are students and universities, teaching staff alike. And to address them, ARRTI uses different approaches and formats, from classical teaching to full online courses and memberships in the Academy. Or, for example, panel discussions like the one we're having tonight. Speaking of responsibility, responsible for the idea and realization of this evening are Alexander Bagattini from KIT, ARRTI Management Director and University Lecturer in Philosophy, Peter Braesicke from KIT, who is Professor for Theoretical Physics of the Atmosphere, Rafaela Hillerbrand from KIT, ARRTI Director and Professor for Philosophy of Technology and Science at the ITAS, and Thomas Leisner from KIT, Director at the Institute of Meteorology and Climate Research and Professor for Physics of the Atmosphere. Thanks a lot for giving us the opportunity to discuss geoengineering and setting up this digital platform for our guests and panelists. And yeah, by guests and panelists, I mean, first of all, Stephen Gardiner, Professor of Philosophy, and also Ben Rabinowitz, Endowed Professor of Human Dimensions of the Environment at the University of Washington, Seattle. His main areas of interest are ethical theory, political philosophy, and environmental ethics, and his research focuses on global environmental problems, especially climate change, future generations, and virtue ethics. Hello, Stephen. Thank you very much for being with us tonight. How are you?
Very good. Thank you for inviting me. It's wonderful to be here.
Thank you. And welcome Hugh Hunt, Cambridge University reader in engineering, dynamics and vibration and fellow of Trinity College. His main areas of work are in the field of radiation management. Thank you very much for joining, Hugh. How are you?
Very good, thank you. Greetings from Trinity College, Cambridge.
Great. And welcome Frank Keutsch, Stonington Professor of Engineering and Atmospheric Science at Harvard University. And in his research, he is interested in how human influence has changed atmospheric chemistry and the impacts this has on humans and the environment. Thank you very much for being here, Frank. How are you?
I'm very well. Thank you for inviting me.
Thank you for being here. And Katharina McKinnon, Professor of Political Theory at the University of Exeter. She's a political theorist working on climate justice and intergenerational ethics and a co-author of the report governing solar radiation management convened by the Forum for Climate Engineering Assessment. Welcome, Katharina. Thank you very much for discussing with us tonight. How are you?
I'm fine, Katharina. Thanks for inviting me.
Yeah, thanks for being here. And welcome Julia Pongratz, Professor of Physical Geography and Land Use Systems at the University of Munich, LMU. Her work focuses on the mutual influence of humans, vegetation and climate. And one focus is on the influence of land use changes on climate, especially through changes in water, energy and carbon fluxes. Thank you very much for joining and discussing with us, Julia. How are you?
Fine, thanks. Looking forward to our discussions.
Me too, thank you. So there is obviously a lot to discuss tonight, and that's why I'd like to jump straight into the topic and first find out what we are going to talk about specifically. And this is because geoengineering, well, it encompasses many different methods from reforestation to direct solar radiation management. And even with the latter, the methods are very diverse. So which methods or approaches are currently the most relevant for our discussion? Maybe Frank and maybe Hugh, you would like to answer that? Who would like to start?
Well, I'm happy to kick the ball off. It is a football season, so I guess that's the right metaphor to use. Firstly, the distinction between solar radiation management and carbon dioxide removal is kind of they're two sides to the geoengineering story. And the carbon dioxide removal is kind of what we ought to be doing, getting rid of the mess that we've made. It's like cleaning up the mess after a party. We ought to be doing that. But more controversially is this idea of solar radiation management. Should we be putting stuff into the atmosphere to increase the reflectivity of the atmosphere to cool the planet down because we failed in our attempt to stop emitting greenhouse gases? And my personal view is that we should be doing all of these things because we're running out of time. But that's a very encapsulated answer to a much bigger question. So does that help get things started?
Absolutely, absolutely. Frank, would you like to add something?
Yes, I think my perspective is probably a little bit different from Hugh's. That I actually don't think we should be doing all of these things. I think we need to understand all of these things much better. I agree that we are running out of time, and this is where I think there's a lot of tension about, for example, how far research should go at this point, where we, in my opinion, urgently need to do more research to understand systems better, whether it's afforestation or what carbon dioxide removal in some form or solar geoengineering. I think we need more research to understand these topics better. In fact, for example, I really hope that we never will have to do or consider, whoever we is, I don't like the word we that much, that solar geoengineering, solar climate intervention, I think is at the moment a highly uncertain topic. But even things like carbon dioxide removal, which addresses the cause of climate change, I think one of the challenges in all of this is that there's research, and then there's the question of everything. In my opinion, everything we're going to be doing in fighting climate change will have some form of impact on somebody. There will pretty much everything we will do have winners and losers. And so really these topics are really something where sort of the physical sciences have to meet with questions of ethics and responsibility. And I think that is what makes this topics incredibly challenging, but also in a way quite interesting. So I think it's merging. You really have to look at both. And one of the problems, for example, is I'm a physical scientist. I'm really uncomfortable talking about ethical questions because I'm not an expert on this. And so I'm really interested in this panel to hear everybody's positions and how that evolves.
So if I can just say, if I had an opportunity to say my bit again, I would have said exactly what Frank said. Frank, you put it extremely well. Thank you.
Yeah, thank you. Hugh, I think you were talking about should we put something in the atmosphere? Like we were talking about the insertion of aerosols in the atmosphere, and maybe we could describe it as well, artificially generated after effects of volcanic eruptions that we would try to produce here. Speaking of those volcanic eruptions, in hindsight, it seems as if it has not been in our hands to predict the global impacts of volcanic eruptions. Would it not be, well, let's say human hubris trying to generate such after effects? Julia, maybe you would like to tell us your opinion on that.
Well, the volcanic eruptions as analog situation to SRM, that was a very old picture, the first one where we really thought we can get a handle on geoengineering without doing our own artificial experiments. And we've learned a lot from it, but we also saw that there's differences, of course, differences in scale, in permanence, and so on, differences in how the system functions. So as Frank already mentioned, a lot is still uncertain, exactly because we're missing the observational basis that we have for so many other things, also related to things that are on the carbon dioxide removal side. We have much better proxies there, much better observations on that side. So it's hard, it's complicated. And this is why it's always proposed to put out more field experiments. But of course, and for very good reasons, there's also obstacles that hinder such applications, even on small scale.
Thank you. Let's talk about controllability, or the controllability of climate change. Isn't climate change uncontrollable enough in its effects? And why should we make even more, let's say, anthropogenic interventions instead of better controlling those that have already taken place, like through fewer emissions, etc., etc.? Stephen, would you like to answer that question?
I think it'd probably be better for Frank and Hugh to chime in on their rationale for wanting to put these techniques on the table. Better for the scientists to speak first.
Yeah.
I can volunteer. I think one of the problems when we talk about controllability is that absolutely, what we have to do is cut emissions as quickly as possible and as aggressively as possible. But due to the accumulated greenhouse gases in the atmosphere, there is a chance that we've already pushed the Earth system so far that just cutting emissions will not prevent, however you may define, impacts that are not acceptable to certain parts of humanity or ecosystems. And the natural way of sort of restoring this, one way I like to phrase it, we've very artificially taken carbon that has been stored underground, and it took millions of years to put it underground, and humans have taken this out and really artificially put it into the atmosphere. And the natural processes of removing that are overall quite slow. And so the problem with the controllability is, if cutting emissions alone is not enough, and I will say that if you look at all scenarios based purely on emission caps, 1.5 degrees Celsius is really not achievable anymore. then the question becomes whether one has to think about additional measures that could restore, get you closer to trying to restore what climate was before. So that's what I phrase why one is considering, in particularly, that one particularly would be carbon dioxide removal. I think, again, that one really sort of directly addresses the cause, and perhaps even what I would call solar climate intervention, reflecting sunlight back. I think that's the motivation, is this question of whether we already pushed the system too far, that emission cuts alone just will not be enough to prevent certain climate impacts that need to be prevented.
I think we have to be thinking that targeting 1.5 degrees, maybe 2 degrees to meet the Paris Agreement. 2 degrees is already a lot. We know that at the end of the various ice ages we've had over the last million years, the temperatures, global average temperatures, were maybe 4 degrees, 5 degrees warmer than they were in the middle of the ice ages, and that corresponded to sea level rises of tens, nearly 100 meters in some of these cases. So you could just do a rough back of the envelope calculation to say that for every degree of warming, we might be expecting 20 meters of sea level rise. Now, we've already had nearly 1.5 degrees of warming. Now, the modeling of this is extremely difficult to do, but the worry is that we are perhaps already committed over the next centuries to very extremely catastrophic sea level rise. Ought we be trying to reverse this in some way? Now, as Frank said, we've already emitted the CO2 that has had this effect, this warming effect. So the question then is, again, as Frank is saying, ought we be researching and developing techniques for really quite rapidly cooling the atmosphere, perhaps so as to avert these really quite dramatic consequences, mainly due to melting of the Greenland ice shelf and the Antarctic ice shelf.
So yeah, when you talk about these effects of climate change, would the alternative to geoengineering be to simply accept climate change? What do you think? What do you all think? Yeah, Stephen.
Yeah, thank you. I think I'd just like to say a couple of things about a wider framing for looking at these questions. So I don't think I'm exactly disagreeing with Frank or Hugh here, but I want to put those points in a wider context. So two things really. The first thing is there are interesting questions around where we are now and how far we're already committed. Some of those questions are ethical questions because I could imagine someone saying, even at this point, it's maybe physically possible to avoid lots of the really bad impacts of climate change if we just stopped emitting tomorrow at 9 a.m. And it's physically feasible to do that because we could just turn off everything that uses fossil fuels, right? So the problem there is not that we're already physically committed to, breaking 1.5 or 2 degrees or even something worse. Rather, the baseline against which we're saying that, we're in real risk of breaking both thresholds is really a baseline that involves some kind of transition that people have declared to be reasonable. And they've declared the transition to be reasonable on ethical grounds. The thought goes something like this. Yes, physically it's possible for us to turn everything off tomorrow, but the impacts on the current generation and particular communities would be really severe of doing that. The agriculture, transportation, everything, heating and air conditioning would be unavailable, and that would cause a humanitarian catastrophe, I think is the background idea. But there's a difference between saying that and saying that the baseline has to be an easy transition that, say, allows global economic growth to continue on a smooth path and so on, right? So we have to be careful about what baseline we're using here. That's an ethical question. And the second issue I wanted to raise is that there's another baseline that's at work here, and that's the baseline of thinking really catastrophic things are going to happen due to climate change. And there's a really strong moral imperative to prevent those bad things from happening. And that's what gets techniques that some people think are very radical, like solar geoengineering, on the table, because there's a catastrophe baseline and the need to avoid that. But of course, if the baseline is avoiding catastrophe, then a lot of radical things might come on the table, not just, technological interventions, maybe social interventions, maybe things like, the need for a global reduction in consumption of certain kinds of goods, maybe the need for population controls, and all these things would make a big difference in terms of climate. And so there's some question about why one, approach that's called very radical, maybe this big kind of technological intervention, is getting a lot of attention and airplay, whereas some of the other things that are also radical are not getting the same kind of attention. And again, to say all that is not to disagree with what Frank and Hugh actually said, is just to put it in a wider ethical context.
So can I ask you, Stephen, if instead of being really radical, what if I were to come up with a technology which would help to create cloud cover, say, for the Great Barrier Reef, to prevent the water from around the Great Barrier Reef in Australia from getting too warm, to prevent the bleaching of the coral? Now, I mean, this is geoengineering. It's a technology called marine cloud brightening, and these things have been tried out, and it all sounds really good because it's, oh, fantastic, somebody is doing something to protect the Great Barrier Reef. But I feel really nervous that this is kind of, oh, the Great Barrier Reef is such a wonderful thing. We ought to do everything we can to protect it. But it's the same technology that we're talking about, isn't it?
Well, I think some of your fellow scientists might dispute whether that kind of intervention is quite the same as, stratospheric sulfate injection that infects the whole planet. But I tend to be a little more on your side of that debate, because I think if you do something regionally on that scale, it will have ripple effects. And it does raise many of the similar kinds of questions. I also think it raises questions about where we are with marine cloud brightening. You sounded as though you thought we were quite advanced in our research and ability to implement it, but my understanding is that we're not. I might be misinformed.
No, I agree with you entirely. I don't think we're at all advanced, but that doesn't stop people from using it.
Well, I don't know if people are using it over the Great Barrier Reef, but I think it raises a broader question here about at what point would implementing some of these supposed solutions count as ethically responsible. As Katharina highlighted, this program we're talking under is about responsible interventions. And one of the concerns I have about geoengineering in general, a variety of techniques, is we're really not very far along. So that I think it's probably not ethically responsible to start implementing many of these things right now, or indeed anytime very soon. So that's a problem. But I also think there are questions about how quickly we could get to the point where we know enough and we're confident enough in what the actual consequences would be, and we're able to govern the things effectively and in reasonable, just ways. You know, I'm worried about how long it's going to take all of that to evolve. So sometimes, for example, people say solar geoengineering is a technique, maybe the only technique that we could use if things start to get really out of hand quite quickly on the ground in terms of impacts. But I worry that it might not be available that quickly in terms of any ethically responsible version anyway. I mean, it's always possible to throw stuff up into the stratosphere and hope for the best, perhaps, though even there we have some engineering challenges. But to put stuff up there as part of a reasonable plan with the sorts of levels of knowledge and the kinds of safeguards and accountability mechanisms that you might need, that's a much bigger challenge and might take a lot longer, maybe longer than we have. And that's one of my key worries about geoengineering.
I just wonder, for the broad audience, I think I want to clarify one thing. I do not believe that there has been marine cloud brightening of the Great Barrier Reef to cool it down yet. Just in case the broad audience suddenly thinks, wow, people have really been doing this. I think what has happened is a few first experimental stages to sort of test out equipment and ships like this. I just don't want people to get the wrong perception that in Australia they're already, you know, doing this. I just wanted to add that for the audience. And I think
you're right, and I guess I'm extrapolating a bit from those experiments to say, you know, what suppose these ideas were actively used at a barrier reef scale to do cooling of the barrier reef, and I guess that helps for me to frame the question of what do we find acceptable and what do we find less acceptable. I mean, the question then is, if we multiply up what we do for the barrier reef by a few thousand times, then this becomes climatically significantly impactful. Should we be doing it?
Since we're speaking about the ethical component, and since it's so tremendously important, may I ask the question? So for me, there's a distinction there between regional applications of SRM, of solar radiation management, like the ones you just mentioned as an example, and the global applications that are really meant to counteract global warming. Because I think on the global scale, we do have alternatives, right? We can reduce fossil fuel emissions, we can reduce land use emissions, we can do carbon dioxide removal and really get at the causes of the problem. And these alternatives aren't necessarily there on the regional scale. If you're saying Australia would now give up all the coal burning and so on, becomes really green, but it's just not enough as long as the rest of the world doesn't do the same. And then for Australia, it may be a fair measure to say we're doing geoengineering on a regional scale to protect our ecosystems, our population, and so on. It may also be more manageable, right? Less risk globally because you think it may be more constrained, but this would depend on the method. Of course, there could be bad side effects for the rest of the globe from such regional interventions as well. But is this something that really ethically has to be made into two separate cases, or is it the same arguments?
Is it worth saying, I mean, perhaps Frank is in a better position to talk about this, that if you put aerosols up high in the stratosphere, very quickly, in a matter of a few days, a couple of weeks, they spread out around the latitude where you inject these aerosols. They spread out, and so you can't target stratospheric aerosols to the barrier reef, say, whereas you can perhaps more realistically target marine cloud brightening to the barrier reef. So they are different, they have different attributes. I think, Frank, would you agree with that?
I will very briefly say yes, because I want to hear from either Stephen or Katharina, because I think these were really ethical questions. What I'll say scientifically is yes, you can't target really with stratospheric geoengineering. That has advantages and disadvantages. However, this idea that you can do a regional intervention of the scale that will cool down the Great Barrier Reef without that having actually impacts in the Earth system elsewhere, I think is erroneous. Everything is coupled. And if you push on the Earth system in one spot, it's going to show up another. Just think about this. Around Australia, the whole, you have climate change is increasing temperatures in different aspects sort of overall. And now you suddenly cool down an area directly east of Australia. That's going to introduce an entirely new gradient in Earth system. And I think one has to be very wary with those things. But actually, I want to briefly say that is because I actually think that Julia's questions were more on the ethical side, which I'm not fit to answer.
Can I pitch in at this point? Just a reflection on the way we've been talking about geoengineering, both solar geoengineering and carbon dioxide removal. And I think it's really important to emphasize that these technologies don't exist yet, right? I mean, they're barely out. I mean, they're not out of the box, really. And that's true both of carbon dioxide removal and of solar geoengineering. So, I think that the degree of uncertainty there is around, what we can and can't do with these, or will or won't be able to do with these technologies in the future is really speculative, right? So where the action is at the moment is around research, I think. I mean, that's what's happening at the moment. Having said that, I don't think that we should, I think in thinking about research in the present, we need to be alive to the direction in which that research is traveling towards, ultimately towards a deployable technology. That's the point of the research. And on that front, just to sort of comment on the catastrophe framing that Hugh was describing and Steve was responding to. I mean, it's true that, we're in a dreadful climate crisis. It's horrifying that we're even having to be discussing geoengineering. We've had 3 decades of just failure after failure in terms of mitigation. And the window is almost closed. We need to be aware that geoengineering has could create its own catastrophes, right? And this is true of both sort of buckets. So for solar geoengineering, it's agreed that, given that all that we do with this type of geoengineering is mask warming, if for some reason deployment were to be abruptly interrupted, there would be a very speedy and large spike in temperatures, which could be even more catastrophic to human and non-human life on Earth than a more sort of gradual climate change and warming over time. And for carbon dioxide removal, the most sort of, I guess the front runner at the moment in that bucket, which is bioenergy with carbon capture and storage, requires land use and water use on a scale that's hard to contemplate. I mean, some estimates are that we would need 1 or 2 Indias in terms of land mass to grow the feedstock for BECCS and similar kind of figures apply to water. And the consequences of that, both for planetary boundaries, but also for biodiversity, which is already in free fall. I mean, if we can imagine 1 or 2 Indias of monocrops coming into existence to make that kind of CDR technology possible on a global scale, it's not as if geoengineering offers us sort of catastrophe-free routes out of the climate crisis. We need to be really aware of what the risks are in geoengineering.
Speaking of the risks, I think there is an interesting question for you, Katharina, here in the chat. Yasha would like to know, or would like to add, geoengineering is probably also only a very short-term delay and could ultimately make the problem much worse, because learning effects lead to greenhouse gas emissions increasing even faster as a result. To what extent is geoengineering a medicine to be relied upon, and what are the social implications?
I can comment on that. And I guess part of what that comment is getting at are worries around the extent to which geoengineering of either type would deter us from mitigation, right? So if we know that we have either solar geoengineering or carbon dioxide removal in hand, whatever that might mean, is that going to incentivize those who would otherwise have made the necessary cuts to their emissions to not make those cuts? So there's a real worry around geoengineering that even by doing the research, so this is, you know, way back from deployment, that even by doing the research we could make a climate catastrophe more likely than it would have been. So it actually could be self-defeating if in fact geoengineering creates this, it's called in the literature the moral hazard, but I think mitigation deterrence captures the worry better. I think that's a really important worry that governance of research, you know, has to address head on and take seriously.
Thank you. So there is another question. Martin would like to know, or would like to ask, doesn't reducing carbon dioxide emissions through geoengineering mean that we are becoming lazy and no longer adequately addressing the real causes of climate change? Isn't there a danger that we will develop misguided incentives and think that we can continue with our consumption-oriented lifestyle? I'd like to, bring that question in, and who would like to comment on that or answer to that?
Well, I think that follows on exactly with what we've just been saying, that we don't want to be letting the fossil fuel companies off the hook. We don't want to be letting our own lifestyles off the hook, and we've got to be. We're going to have to change the way we generate our energy. We have to change our lifestyles so that we consume less and we become less wasteful. A lot has got to change, and there is no question at all that if geoengineering were ever to be adopted, the underlying assumption has to be that we've got to have addressed or be addressing head on all the other issues to do with emissions reductions and greenhouse gas removal. If we're not prepared to address those issues head on, there is not much point in doing geoengineering at all, because it's not going to solve the problem. It might buy us some time, but that's about it.
If I can add that, I think I'll just sort of actually pose a question of my own within this context, and that is, to what degree should one be doing research on this at the moment? And I'll say my personal opinion is that I think if we were in an environment where we really have the feeling we're doing as much as we can to reduce carbon emissions as quickly as possible, that would make it, for me personally, much less challenging to think about whether doing this research is actually, whether the downsides may outweigh the upsides. And I will actually just want to throw out that the verdict by the German Constitutional Court that sort of really pushed Germany towards saying you need to have much stricter laws to really cut emissions so that future generations don't get burdened as much, are the kind of science that I'm hoping to see, because that makes me more comfortable about doing the research, because I have the feeling we're really on a trajectory where we're trying to really cut these emissions. And I find it a very challenging question to what degree. I'll tell you what my quandary about this. My quandary is, if we don't do the research now, and as Stephen said, and I don't just mean physical research, there's governance, there's ethical, there's all these aspects, which to me are all research, some of which I don't understand at all. But there's a lot of research that needs to be done. If we don't do that research now, will that prevent people in the future to actually still think about using these methods? And I obviously don't know the answer for that, for me, that is the reason to do research now, is this worry I have that these methods, these ideas are out there. At some point, people may pursue them even if we haven't done that much research, or is doing this research just in itself going to make it so much more likely that it'll be used. And I actually want to add one more thing where I want to disagree a little bit with Katharina, that I am doing the research I'm doing not towards deployment, but for example, because I'm very concerned about some of the effects stratospheric geoengineering may have on overall circulation because of heating of the stratosphere. It's very specific, but you know, I just want to make clear, I'm doing that not towards deployment, but because I'm actually worried there are some things we don't understand well enough yet. But to me, this is one of the questions that just I'm personally grappling with, is where, you know, at what point are the conditions such that doing research now is okay versus the risk, the time we're losing by not doing research?
One may want to add that doing research to arm the future, that this may also lead to the result that the risks are too high, that we find out it's just not a good solution. We were too optimistic. We were not accounting for these and those side effects that we may see in experiments, or may see by doing modeling, see how the atmospheric circulation changes, how side effects on other biogeochemical cycles will emerge, and so on. And this could also be a strong point if we're aware now of that many of the geoengineering options are really bad solutions when you consider all the side effects. If we had a much better understanding there, much better grasp on the numbers of the risks and the uncertainties around it, then it may also put more pressure, in fact, on us trying to mitigate climate in the conventional way by reducing fossil fuel and land use emissions. So I think research is definitely what we're needing now. It may lead us to having more confidence in these methods. Then this is a good case if we really should need them as a kind of emergency measure. But it may also tell us that it's really risky, this path that we're taking, and this will put more pressure on us trying to reduce the actual cause, which is the emissions.
Katharina, yeah.
I think that's interesting, and I would push back against it a little bit. I mean, I do wonder whether, you know, there are plenty of instances in which we have technologies which are suboptimal and maybe offer us bad solutions to the problems we have, but we've nevertheless, you know, locked into those technologies as a result of sort of various processes and incentives that get created as socio-technical systems around research programs evolve and kind of take on a life of their own. So, I mean, while it's true that, you know, more accelerated research could be beneficial in kind of really highlighting to us what won't work and what the risks are, and maybe those risks will turn out, you know, to be just unacceptable, and certain research programs get shut down. I think the picture is a bit more complicated in terms of how research programs can acquire almost a life of their own, and you end up in places with technologies which dominate you know, the solving of a particular problem in a social context, even when they're not the best technologies and the best solutions that we could have, because we socially collectively have locked ourselves into those technological solutions. That's a worry I have about particular solar geoengineering technologies, sort of and research programs which might be running in parallel. But also I have worries about how we could end up locking into a deployment scenario, even though we never meant to do that. Right, and it was never our intention in accelerating research. I think we really need to be alive to those possibilities, because we know, you know, we've got evidence of this happening already in socio-technical systems.
Yes, we've not been very good as a human race in if we invent something, we tend to use it. We don't tend to develop something and think, oh, that's nice, and then put it away and not use it. We've not got a good track record on that.
I agree, although I would just briefly say that there are some examples. It doesn't always happen. I mean, ocean fertilization is, I think, an example where that actually the opposite happened. But again, that doesn't mean it happens. I would also say that, for example, using gene-modified crops is something where there's very regionally different opinions by people about this. And, I think also, what I want to say is that even if it so happened that one method of carbon dioxide removal or solar radiation management shows this looks really good, populations can, for scientists, it should be clear that if populations decide they still don't want this, that's entirely okay. That's, as a physical scientist, I see myself only there, and that's a little bit of a cop-out and not wanting to deal with the hard problems, but I'm here to provide scientific facts. I'm certainly not trained or have a mandate to sort of go beyond that. I want to make that clear.
So may I add to this conversation? So one way I've put this, or part of this issue in the past, is to say we face a paradoxical kind of question. I mean, many of the arguments for motivations for doing research on geoengineering are overtly ethical. It's about protecting against severe impacts, protecting future generations, and so on. But you might say we're in a situation where we have moral obligations, ethical reasons to act on climate change, but we've had them for a long time. And in the past and now, and predictably going forward, we have not acted as we should. So the paradoxical question becomes, what should we do given that we have not, are not, and probably will not in the future do what we should do, right? Because I think everybody in this group probably thinks we should have acted decisively a few decades ago. There should be ongoing action now that's much more extensive than it currently is, and so on. And one problem that comes up when we talk about geoengineering is whether we're imagining doing the research and then maybe moving towards deployment in a world that's acting very strongly on climate change, which is as it should be, where the moral obligations, the reasons are being respected, versus the world we're actually in, which is characterized more by profound, somewhat amazing political inertia, and in the face of this huge global intergenerational threat. Right? In that sort of world, how can we expect these things to evolve? And I think this is important in part for Frank's question, but much more broadly. Why Frank's question, I mean, what are the implications for the obligations of research scientists? What are the obligations for philosophers and political theorists and other people working on these things? Right? Is a live question that's just complicated by our terrible geopolitical situation around climate change. Because it's one thing to have good intentions for everybody in those groups to have good intentions, and another thing what the effects of our doing the various kinds of research will actually be. I mean, for instance, it was already hinted at that some forms of geoengineering might actually make things worse for future generations, might make the climate threats worse in the future, because we're very, very early in thinking about these interventions. It's all very speculative. There are also worries that have been, maybe in the background hinted at around if people start doing regional or global interventions to protect their own countries, right? We might see a kind of geoengineering arms race evolve, where Australia does something to try to protect itself against severe heat waves and protect the Great Barrier Reef, but that has effects on Asia that makes the Chinese want to do a counter intervention to prevent certain kinds of effects, and so on. And that might be one of the most dangerous scenarios coming out of this whole story. And so I think these kinds of worries fuel a lot of background attitudes about whether it's reasonable to and ethical to proceed and what way we should be proceeding. And in the background, of course, there's this massive issue of, if you are going to do particularly solar geoengineering at the global level, it seems like you absolutely would need good institutions at the global level to govern it. But it's the lack of those kinds of institutions that's arguably put us where we are today, with not having anywhere near sufficient mitigation. In fact, we keep increasing and increasing emissions, and with all the other problems associated with climate progress.
I mean, that raises the question of, what would you do about unilateral deployment if some billionaire somewhere decided just to go ahead and do it? How do we deal with that? And then the other question, I guess, phrasing it another way, Stephen, is whose hand ought to be on the thermostat? There's no answer to that at the present.
Katrina, do you want to respond there?
I'll go quickly and then I'll go back to you. I think we do have an answer to that, Hugh. Right? I mean, I think you know, a savior billionaire with his, and it probably would be he, hand on the thermostat, deploying this stuff unilaterally would be an awful scenario, right? I mean, there would be no political legitimacy, there would be no accountability, right? The long-term public interest and you know, the rights of future generations would be very unlikely to be secured by that kind of deployment. I mean, that's, you know, that's the kind of very worst vision we could have of that. I mean, how do we prevent prevent ourselves from getting into that situation? Well, we need to start thinking about the governance of all of this right now, right? I mean, and governance not just in the sense of voluntary codes of conduct for researchers, right? There needs to be international coordinated oversight of research that's being done in such a way as to, you know, minimize the risks of the kind of evil genius with the hands on the global thermostat, and we don't have any of that at the moment. I mean, there's lots of sort of reports. I was involved in one of them, which I think say very, very similar things about legitimacy and transparency and tracking what research is being done where. But in terms of action, at the moment, we pretty much have a governance vacuum. And I think that's very dangerous if we are going to proceed with the research. Steve, sorry.
Thank you. Yeah, I agree with that. I think I would add that, you know, from my personal point of view, I think the idea of one billionaire, or sometimes it's phrased as one small country like the Maldives that's, you know, facing a serious threat, you know, some plucky individual country rising to the task, and geoengineering, and everyone else saying in a certain way, well, maybe we don't totally like it, but good for them. I think this is a really fanciful scenario, in my personal opinion. I don't see the major powers permitting some individual or small country to effectively try, at least, to take control of the global climate system with, you know, very significant effects everywhere. I mean, the whole point is to have significant effects, right, to prevent bad climate impacts, but we don't know whether that would actually succeed, and we don't know what the bad effects would be. We might call them bad side effects, but they might actually turn out to be the main effects. It's hard to know when we know so little. But I don't see the major powers permitting that. So if it were to happen, it could only happen with, you know, implicit backing from the major powers. I think our more serious concern, you know, geopolitically and about the kind of threats that are likely to emerge, would be around some large country that is a major power and maybe has, you know, nuclear weapons and so on, intervening, and then what that what effects that causes around geopolitical stability. For example, in the US, which is my home country, I think a lot of the conversation about geoengineering just tends to assume that it will be the US doing it. And I'm not sure that that's a realistic assumption later in the century. I'm also not sure that the rest of the world will be completely comfortable with the US doing it. It might depend on what kind of leadership is in control in the US. But people look at this problem very differently if they're thinking about, geoengineering by their major geopolitical rivals than they do when they're thinking about doing it themselves. And I think we should take those kinds of issues very seriously.
So there are more and more questions in the chat piling up. Mara would like to ask about the specific criteria which can be used to weigh up the risks of geoengineering techniques. She says it sounds very easy to solve our climate change problems with technical means like solar geoengineering, but of course there are risks here too, perhaps risks we don't even know about yet, just as there are risks if we do nothing to counter climate change. And so her question is about specific criteria we could have to weigh up the risks.
I'll get started on it. I think the challenge there is that it's really hard to come up with specific criteria because everybody in the world will have a different opinion about which criteria are important. Perhaps not everybody, but there will be a large diversity about what criteria are important to them. So I think that's actually an extremely challenging task to find out. You can go to like the catastrophe scenarios that we had talked about earlier, which I don't really like because I think they're not useful. I think you can say, well, perhaps, studies will show a catastrophic outcome and then it's easy and the risk is very big. But, it may be more likely that you're going to find, there's different risks of different type and the risk will vary by region and different models will give you different predictions. And I think the challenge then becomes that different groups will have different views on whether a risk is acceptable or not. And I actually think this all goes to these ethical. I think it's easy to get some physical answer and there'll still be unknown ones we don't know about. But the challenge, in my opinion, is what does it mean if, I can, get you a number for some risk, but some people may think this is acceptable, some don't. So I think it's actually really difficult. That's where we need to have governance so that people can start talking and people can start understanding other groups' positions on things. Like I was saying earlier, there may groups who say even if geoengineering looks pretty good, they may say, we still don't want that. We just think this is wrong. How do you deal with these different views? I think that's really where the challenge is.
So what we know from modeling that has been done to date, and modeling is not perfect, we know that, it's very imperfect, but it looks like if we use some kind of geoengineering technique to control temperatures in a certain region, it's very likely that we would have rainfall issues in another region or in the same region, perhaps. So we may do perhaps what we want to do in terms of temperatures, but we may do some really dramatically damaging things in terms of rainfall. And I think this goes back to Frank's point right at the beginning, where the urgency, if ever we're minded to be deploying, and I hope we wouldn't, but if ever we're minded to be deploying anything like this, we have to have done extensive research to be really mindful and cognizant of the potential impacts we can have in so many ways. Impacts on agriculture, impacts on land use, impacts on the oceans, impacts on the Arctic, impacts on in so many ways. And we're not ready at all to answer any of those questions. So how do we weigh up the pros and cons? Well, we just don't know what the pros and cons are yet.
Is it not true as well, though, Hugh, that actually, you know, we will never know what the pros and cons are until and unless we actually deploy, right? That we don't have a spare planet Earth that we can go and test this stuff on. So the kind of logical end point here is that you test through global deployment. Well,
that is true. That is true. But then I would also argue that we won't know if we do nothing, then we don't know what will happen either. And this is the dilemma we're in, that we've got to do everything we possibly can to stop burning fossil fuels. I think, you know, that's clear. I do believe we ought to be doing whatever we can to remove greenhouse gases, but that's not entirely uncontroversial. Our Centre for Climate Repair last week had a session on ethics and governance of greenhouse gas removal, which was absolutely fascinating. That greenhouse gas removal has this mitigation deterrent effect, just as solar radiation management does. So we could ask the same question: would things be different if we chose not to pursue greenhouse gas removal? Gosh, no, we don't have a very good crystal ball, that's for sure. But we don't know what would happen if we did nothing, and we don't know what would happen if we did something. Boy, research on all of this is so desperately needed.
I would just like to add that I think that's a little bit of an extreme framing of the conversation. It sort of says that either you know nothing or you know everything. I think the point of research is not necessarily that you'll know everything. I totally agree that, you know, to really know what it would do, you'd have to do it, because even given climate variability, the models may not predict it. But that doesn't mean we can't learn important things. So I actually I'm not really a fan of framing these things in this sort of this really all or nothing perspective. I think there are things one can learn. I think there are, you know, I think we do know some things that models seem to be reasonably well at. Others we're not so sure with. So I think there are things with more research that we actually can learn that hopefully are useful. Perhaps not. They will certainly not answer everything. I totally agree with that. But I just want to sort of pull back a little bit from this all or nothing discussion.
Frank, I think
also on the all or nothing point is that geoengineering, if we ever go down the route of deploying it, it's not an all or nothing thing either. That we would do whatever necessary first steps, monitoring very carefully what these first steps, what impacts they are having. I use as an analogy that you know, we're very happy putting chlorine into swimming pools to keep the pools clean, but chlorine is an extremely toxic chemical. Now you wouldn't put a really toxic chemical into a pool and jump into it. You know, you do it gently, and now we have established a protocol for putting chlorine into the pool. But I think that we've just got to be aware that whatever research we do, at some stage or other, has to involve full scale, full size, low scale experiments, because the experiments cannot all be done in laboratories. So, you know, we can't be, computer modeling has to be validated at some stage. So I think it's important, for instance, that we get to a position where we can put small quantities, very small quantities of climatically active materials into the atmosphere and see what impact they have, but on such small scales that they do not have an impact, but so that we learn about the models and whether the models are working properly.
So I just wanted to respond to something that Frank said earlier about, how we're going to agree ethically on what principles might be adopted. So small plug, a couple of years ago, I put out some ethical principles that might serve as a framework for thinking about geoengineering, and really a guide to what the salient kinds of considerations would be. They don't solve the problem that Frank suggests of getting widespread global intergenerational agreement on the specifics, but they at least provide a general framework within which to think about what the relevant questions are and make sure that they get answered. One reason I thought it was worthwhile putting forward those principles, the tollgate principles, as I call them, is because I think in context, there is a bit of a risk that we adopt too simplistic ways of talking about the problem that are not very helpful. So there's a tendency among some scientists to, maybe for reasons of economy, so on, to speak about climate interventions in ways that make them seem sort of ethically one-dimensional and quite easy to think about. So you see people saying, well, if we did this kind of intervention, it would benefit everybody, right? Which is, once you start thinking about it, almost self-evidently false. As Frank mentioned earlier, there are obviously going to be winners and losers, and depending on which baselines you're talking about, there are complicated questions as well. But I think having some frameworks within which to have the right kinds of conversation is useful, right? And can stop us going down, blind alleys. And, all of us are guilty at one time or another of being a bit too simplistic, especially when we're talking to public audiences. It's hard to get communication right. But for example, I would say, Hugh said earlier, I think just a slip, said we should be doing everything we possibly can, right? Well, there are lots of things in the realm of possibility that we could be doing, right? Including, as I mentioned earlier, turning everything off tomorrow morning is something we could possibly do, right? And there are some also really egregious things that could be done, some of them which are the themes of popular movies like The Avengers and Thanos, wiping out, I forget, is it a third? I forget what the percentage is of the people on Earth in order to, bring down the environmental impact. There are lots of things that are possible, but many of them seem, very seriously unethical. So we have to pay attention to what the ethical parameters and guidelines we want to work within are. And this is, of course, a massive area for future research, because we're not particularly well developed in thinking about problems that are global in general, but also very specifically intergenerational. This is not our strong suit, institutionally and theoretically yet.
So I would like to bring in some more questions from the chat, and there's one for Julia. And Hubert would like to know what role can or should the retrievability of geoengineering technique play?
I'm sorry, I don't quite understand the question.
Yeah.
What's meant by retrievability of geoengineering? Yeah.
Let me check if there are more, if there's more in the question. No, that is what Hubert asked. Maybe it's a question for all of you, and maybe you can discuss what the question might cover, and maybe Hubert would like to pose this question again in the chat. I will let you know if he's asking more.
If we have time, I'd like to clarify something on CDR versus SRM, if that's possible, because I think much of our discussion hasn't been quite clear what we're exactly speaking about. For example, when Katharina mentioned before that we were not ready to implement any of the geoengineering methods, I think it should be specified that this is, of course, referring more to the more heavily technological solutions like marine cloud brightening. We in theory, we could deploy, we have ships that could go out and spray things into the atmosphere there and clouds would form. But of course, it's not something that we've regularly done. Same for space mirrors and stratospheric aerosols. We could do it, we've done it and to some extent, but this is different from carbon dioxide removal from most of these methods there. Because many of these CDR methods, they are implementable now. Why? Well, because some of these methods we've already implemented for 10,000 years. We started agriculture, we started clearing forests, we started regrowing forests, and this is exactly one of the prime solutions that people put out to if we don't want to reduce emissions, we can take up a lot of CO2 via afforestation, reforestation, for example. Biomass plantations is something we've always done. We always lived off biomass prior to the fossil era. The only new thing is now that we do carbon capture and storage with it, but it's again something that's readily available now. And because it's vegetation based and we've done land use for 10,000 years, we know a bit better the side effects of this as well on energy and water cycles. We also know how it looks like. We know how it would affect tourism, recreation, aesthetics, education, and so on, a bit better at least than for those SRM methods. And so I think sometimes it's important in this discussion to separate SRM from CDR in that respect. And CDR, one must say, when we're speaking about the implementability and maybe this retrievable question on climate engineering goes in that direction as well, one must say that CDR is about to being deployed. It is already in small scale. We're doing afforestation, and many of the national climate policies that we see, they rely on CDR. So maybe not fancy methods like enhanced weathering or biochar that much, but on most climate protection plans, you see that forests play a role, that biomass usage, bioeconomy, bioenergy plays a role in there. And in particular, when you think of how climate goals have to be distributed across sectors, you come back again to one sector that's really problematic. So in most sectors, energy sector, for example, you can really try to reduce emissions. But in the land use sector, it's much harder because as long as we manage the land, there will be nitrogen, so N2O emissions, laughing gas or methane emissions and so on. And then you need to counteract these emissions in that sector by active negative emissions. So there's not so much you can do with just reducing the emissions into the atmosphere. You really have to create negative emissions. And this is why in that sector, the land use sector, CDR is already a big part of the agenda. And also it's doable. So of course, Katharina, the aspects you brought up that there's, do we have enough land for doing all this? It's very valid discussions, very relevant ones that we have to have, but there's a lot we can already do. So if we have a high enough CO2 price, beyond $100 US dollars per tons, then we can clear up a whole lot of land because we have the money to intensify agriculture. And we can provide land that we can use for BECCS, for afforestation, for example, at no interference with food security. And so I'm stopping here, but this is CDR is in many respects very different from SRM, and in many respects very similar too when it comes to some of the unintended side effects when you go to large scale.
Can I just comment on that, Julie? It's really interesting. I'm really glad that you've talked about that. I think natural climate solutions are you know, in this sort of basket of things that we could do other than, you know, reduce greenhouse gas emissions and do solar geoengineering or BECCS. You know, there's a whole kind of bunch of things that you know, if done in the right way, could be win-win, right? So increased deforestation, etc. Right? I mean, it's good for the climate, it's good for humans if you do it in the right way, it's good for biodiversity, etc. But I mean, you'll be able to correct me here, but my understanding is that, you know, even in sort of best case projections of these sort of natural climate solutions, they're not going to have a sufficient impact in terms of negative emissions to make a sort of meaningful contribution to movement towards the Paris targets, for example.
Well, it's clear that we're not going to get away from large-scale reduction of fossil fuel emissions. That's entirely clear. But it may ease the path, right? That's the hope of many. And a lot of these methods people are still looking into, and you could also possibly use the land for 2 or 3 different methods. You can put out biochar on the soil. You can grow biomass plantations on top of that same soil. And then potentials may add up to a substantial amount, not one sufficient to relieve us of the pressure to reduce fossil fuel emissions very substantially and very urgently, but to ease the path, possibly also a bit in this direction of the emergency tool that we're often discussing in terms of SRM. And when you look at the potential, so we're currently emitting about, well, on average over the last decade or so, about 12 petagrams carbon per year. And each of these individual methods that you have for afforestation, for biomass plantations and so on, they could be about 1.5 petagrams carbon per year that you remove by this. Partly on the same land, but partly not. But you could add it a bit up. So the hope is that that we create sinks in CDR that are as big as the natural sinks that we currently have on the land. Just by itself, the about 1/3 of the emissions that we emit each year are taken up naturally by the ecosystems. And the hope is, in some scenarios say so, we could create equally big sinks by active CDR. But it's tough, and we need to manage wisely the land, of course, and we need to consider the side effects beyond the climate on society, on economics, and so on.
And also, just to bring up something that Hugh mentioned earlier on, the CDR, even natural climate-based solutions, CDR, have the potential to deter mitigation as well. That isn't just a problem that attaches to solar geoengineering. So I think that for that reason alone, right, ethically informed governance would be needed, even of this sort of, the sort of nicest part of the bucket of CDR, right? I think if we have that, if that's a reality that we could end up deterring mitigation, or if we could, the natural climate-based solutions could, in a worst-case scenario, stand as an excuse for extractive industries to sort of continue to extract. That could be an unintended consequence that could be really disastrous for the climate.
I'd like to make a little side point here, which is just that there is, in some quarters, a lot of enthusiasm for these kinds of CDR techniques, and perhaps for good reason. But there's an interesting ethical issue around the fact that mainstream climate projections are already assuming that we're going to do such things, and on a massive scale, starting in about 10 years. And a lot of this stuff is not yet proven at scale, yet we're assuming that we're going to be able to do it, and we'll be doing it on a massive scale by the end of the century. So I think that's important, both because I wouldn't want people watching this to get the impression that there's some big substantial new thing that's going to come in and save us, because the new thing is being factored in. But I also want people to think about the fact that we're assuming the deployment at a very large scale of technologies that are as yet, somewhat unproven, at least at the scale envisioned. And, significant scientists have said that this is a really big ethical problem, and that we shouldn't be modeling things in that kind of way. And I wonder what Frank and Hugh and Julia think about that.
Yeah, that's why I try to say that it's not taking any of the urgency of reducing emissions away. And indeed, so when you look into how we can reach the Paris Agreement's goals, for example, or stay below them rather than reach them, we don't want to get up there at all. And it depends entirely on how good we are at the mitigation, if we need CDR, or how much of the CDR we need at which scales. And indeed, as you say, some assume very large scales where we currently have no idea how we're going to get them. Some medium-sized scales where we could think if we have a high enough CO2 price, we would have the ability to perform CDR at that scale, because some of the methods are ready, right? We have seeds of trees. It's more about the governance of the land. Who owns the land? Do we have to install new rules of saying who can plant the trees? Are we going to make sure that farmers out in the jungle who are relying on that land, that they're not going to clear that forest 5 years from now? We need a monitoring system and so on. So there's a lot of issues still there, but there's also more graspable solutions than the SRM is in that respect. But clearly, so it's in some of these scenarios, if it's not good at the mitigation side, it's entire hubris to think we can deliver this this much CDR to get us off the hook on the mitigation side. This is very clear. But we need to see that. So we're often also mixing up emissions and CDR as if it were two separate things. And in the end, it's really the same thing. When you think of, we're emitting a lot of CO2 from deforestation currently, from the agricultural sector. The CDR would be in the same sector. It would be land use as well. It would just be that we're turning around it into negative emissions. And so therefore also some of the ethical issues are some that we have already seen in the past on the emission side, now with the change of sign.
If I can ask a quick question. I actually agree that in some sense the uncertainties for these methods are lower. But one thing I'm always confused about is, you know, if we are doing this on a big scale, what natural methods really still means. If you know, what is natural? If we are interfering in nature, to what degree is that really still natural or not? And the other question, both for that and CDR, depending how we're doing it, how well do we understand the long-term storage of carbon in the system? If you grow a new forest, you know, as it's growing, the carbon gets removed from the atmosphere, but then it's all about the long-term storage. And I think that's what in the end for ocean fertilization sort of showed that it's probably not a good idea because it isn't really stored long-term. And so how well do we understand for all these different methods? And this is more for my education, how well do we really know the long-term storage of the carbon for these different approaches that are being suggested?
Yeah, that's one of the big research questions. For example, with the forest, looks good, sounds nice, but how much carbon you can store in the forest themselves depends very much on how the climate will evolve in the future. We're already seeing now in Central Europe, everyone will know we've had 3 severe droughts within a decade now, and you see the forest suffering. And if you're more going towards a 2-degree goal than a 1.5 degree goal, it's clear we're going to see more of these droughts, and the permanence of the carbon out there in the forests is not at all clear. So then there's the discussions, what else can you do? You can remove the carbon, put it in very long-lived products, building houses that stay for centuries. You can bury it, but okay, what happens with the soil if you disturb the soil so much? You can try substitute energy-intensive products like cement production, steel production, all requires a lot of energy or emits CO2 in itself. So that's a good thing if you could replace that by woody products, for example, but there's only so much potential. Sometimes in some countries we have even laws how tall woody buildings are allowed to be currently. So there's a lot of obstacles to that. And yeah, that's a big part of the research currently, this CCS part and the storage part in particular. You think of, you could pump it into the ocean and it stays there, and then if you go deep enough, it's going to stay there for a while. But of course, around that CO2 lake down in the ocean, everything's going to be dead. And then eventually it's coming up with the ocean circulation again. So this is a tough question. And the not in my backyard discussion too of having the CO2 pressed into the underground at the risk that it may come up at some point again. These are really tough questions. We're much better on the how to suck it up than where to store it in the very long term, at least. And when we speak about future generations, it's this very long term that we need to be concerned about too.
But Julia, you say we're much better at knowing how to suck it up. I'm not sure that we've got that at 10 billion tons a year scale yet. And yeah, that goes back to this this point made earlier, that the Paris Agreement has this implication that we're going to be doing tens of billions of tons of carbon dioxide removal, but we haven't got even 1% of that ready to go yet. It's a bit of a worry.
Yeah, this is putting the urgency on reducing the emissions.
Hugh, there is a question for you in the chat. Ricarda would like to comment and like to ask you something. Mr. Hunt already started with the phrase that we are running out of time and also mentioned the typical buying time argument for geoengineering. Doesn't this buying time already imply that we can longer behave as we do now without a transition towards increased mitigation efforts? Shouldn't we be more careful with terminology that we use for describing the technologies and their potential effects, the framing issue? That's the question.
We absolutely need to be careful, and I'm not always very careful, and I'm first to admit that. But where I think on the timescale for me is the prospect of the Arctic being summer ice free, and this is looking like the Arctic will be summer ice free perhaps in the next 10 years or so. I mean, we don't know, but it's really looking pretty bad in the Arctic. Once the Arctic is summer ice free, I think that changes the way we have to look at where the climate is going. So for me, that's the time scale. We've got to try to prevent the Arctic from being summer ice free. And I don't believe that we're going to do that by emissions reductions alone. I very much hope we could, but I just don't believe we will on that time scale, which is why I think we really do need to be doing carbon dioxide removal at scale. And then when I talk about buying time to get those carbon dioxide removal technologies going and to get our emissions reductions going over the next 10 years, I think that's unrealistic. And we might need a bit more time to do that. That's the argument. But we must not slow down on our urgency to do all the important things on emission reductions and on carbon dioxide removal.
Yeah, thank you. And we're just looking at the watch, and we're slowly approaching the end of our discussion already. And so I would like to give you the opportunity and the chance to reflect our discussion a bit and maybe comment it and tell us how you like the discussion, also the questions that were coming up. Starting with you, Stephen, how did you like the discussion?
I liked it a lot. I enjoyed it. I think there's a lot of common ground in the sorts of concerns that are being raised, across disciplines. There's a lot of shared background concern about the context in which we'd even be contemplating these things. I'll just mention one thing that hasn't come up, which is just that some people, not me, but some people have been very strongly arguing that we shouldn't, take even a step down this pathway by doing any research, because they think the SRM in particular is just ungovernable. And I assume that because of that lack of governability at the global level, they think it's very dangerous to take any steps down the path. Again, that's not my view exactly, but I think it's a view that's worth putting on the table that people should think about.
Thank you. Hugh, what about you? How did you experience the discussion?
I always find these discussions extremely interesting, and always I learn something new, and fantastic that you've gone to the trouble of putting this event on. Thank you very much.
Yeah, thank you for joining. Frank, what about you? What would you like to mention and to add?
Yeah, I think it was a very interesting discussion, and from my perspective, one of the things that I have been realizing more and more is that despite our busy lives, one of the things that's really necessary in this context are more conversations between people from different backgrounds, different research. I'm a physical scientist. I'm actually always very wary about talking about these governance and ethical questions, because I feel that's like a social scientist telling me about how calcium carbonate reacts in the stratosphere. But I think for understanding each other and understanding these perspectives, because we're all very passionate about what we're doing, it sometimes takes time to hear voices and understand what people are saying. And so I actually think it's really important to have more of these discussions. And I actually think including both solar radiation management and carbon dioxide removal, because even there's different communities. And it's really useful for those to get a better understanding of each other. So I really think these discussions are quite useful. And that was just for me personally. I hope it was also useful for the audience, but I can't judge that, of course.
Thank you. Katharina, what would you like to add, to mention?
Yeah, I mean, I echo everything that everybody else has said. I do think these sorts of conversations from disciplinary perspectives that are that really work in very different ways and whose paths don't necessarily cross. I think having those conversations in a public forum is really, really important. If we're to have if research is to go ahead and we're to achieve governance of this in any way that's politically legitimate, it has to be the case that public awareness of the technologies, but also the sort of social, ethical, political, legal questions that are all bound up in the research programs themselves. That kind of level of public understanding has to be really quickly brought up, I think, and it's through events like this that will happen.
Thank you. Julia.
Yeah, I can also only second that. So what makes climate change and our not tackling the problem harshly enough, so what makes climate change so complex is exactly this multidimensionality of it. And sustainable solutions can also only be found when we really cross all these disciplines, from ethics, policy, natural sciences, economics. We didn't have very much here, but all these aspects need to be put together to really have a full comprehensive evaluation of the different methods that we have at hand and may not have at hand. And in the end, it needs to be implemented, whatever the mitigation, the CDR, the SRM, or whatever. And so the public awareness, the public opinion is very important. And so thanks a lot for the opportunity to speak here.
Thank you. Thanks for this, for this great discussion and for the perspectives. I think they helped us to, better situate geoengineering in a field of controversies. Thank you very, very much, Stephen, Hugh, Frank, Katharina, and Julia, for being here and for this discussion. And as I said, it helped us to better understand or to find our own opinion in this field of controversies. And by us, I mean everyone who has joined and watched and listened and participated with all the questions. And we were trying to cover as many as possible. Of course, there were many, many more. Thank you very, very much for all the great questions in the chat and Twitter and through via email. Thank you all for watching and discussing and being part of this ARRTI panel discussion. And I hope to see you again soon in the next exciting panel discussions. But for now, take good care and bye-bye. Thank you.